Welcome back, everyone. We are back to our final lesson on indices for now. So something might come up in the future. So indices and exponential functions. So there are situations where if you're given questions like this, x could be anywhere. Your unknown could be your index. Your unknown could be anything, just be anything. So and then your job would be to find that unknown. So I've written a different form. So in the first one here, the our unknown is a base, so which is x. In this other part, our unknown is also a base. And in this third part, our unknown is the exponent. So this is like three different versions of how a question can be asked, and it is still indices. So this is not the only thing we have to do today. We're still going to be talking about more exercises. Then the way we the way we roll, right? Yeah, that's good. So solution. When we see x raised power 1/3, what we can do to get x here, there are different ways, but I just want to teach you like a simple method because that's my job anyway. Equals 5. The power of 5 here is 1, right? So what we could just do is that we could multiply the powers on both sides by the inverse of the power of x. So what's the inverse of the power of x? It is 3/1, right? Because you have 1/3. Because what we want to do is that I want to cancel this power. Like that's just what I want to do. So to cancel this power, then we have to multiply both sides. Multiply the power on both sides. Multiply the power on both sides. On both sides by 3/1. So 3/1 happens to be the inverse of x and the inverse of the index of x here. So that will give us x raised power 1/3. Then this power multiplied by 3/1 equals 5 raised power 1. Then multiplied by 3/1 as well. So this cancels that. So this cancels this because 3 cancels 3 here. And then we are left with our x. X stands alone. X equals 5 raised power 3. 5 raised power 3 is 125. So that means our x is 125. And that's it. Yeah, true. Then for B, 3x, whenever you have questions like this, it simply means that the other part of the equation is likely to be expressed in the same base as what is here. But not necessarily the same base, but this is like coefficient of x here. And yeah, let's even say the same base. Like there's a point that it's likely I can express it in the same base. So what do I mean? You have minus 27 here. So minus 27 on its own is 3. Well, let's do it like that, like minus 27. Maybe like that. So what we need to get our x. So we divide both sides by the coefficient of x. So the coefficient of x here is 3. So that makes things even easy. Divided by. Coefficient of x here is 3. And this one too is 3. 3 cancels 3. X raised power minus half equals minus 9. Okay. So from here, like the same thing that we did in that side, multiply the power or multiply the index on both sides by, so the inverse of minus 1/2 will then be minus 2/1 and minus 2/1. So when we start, x raised power minus 1/2 multiplied by minus 2/1 will be equal to minus 9. The power here is 1, it's power 1 times minus 2/1. So 2 here cancels 2, this cancels this. We have x raised power 1 equals minus 9 raised power 1 times minus 2 minus 2. 2 is equal to minus is equal to 1 divided by minus 9 then raised to power 2. I don't know if you get what I'm trying to say. So since this was minus 9, anyways, it was minus 9. So 1 over the minus 9. It is the minus 9 that is carrying the index down. So we are supposed to have 1 over minus 9 squared is 81. So the answer here is 81. It's 1 over 81. It's not 1 over minus 81. Alright, so again, the reason why that changed is because we had a minus 9 here. So if you have a 1 over, so it's meant to be 1 over the minus 9 still. The minus 9 carries its own squared. So minus 9 times minus 9 is going to give us just 81. So that's about that. Then the third question, C, equals 8 raised by x equals 0.125. Whenever you have a question like this, it simply means that there's a chance that you might also be able to express what's on this side, in terms of x. So how do I do that? I'm going to apply my standard form. So how do I correct this to, I want to get like a fraction, not like a decimal. So 0.125 will then be equal to, this is over 1, will then be equal to, I shift this by one decimal point, I need to add a 0 to this. Shift this by another decimal point, I need to add a 0 to this. Shift this by another decimal, I need to add a 0 to this. So my decimal point is here now. Alright, so I'm technically having 125.0 divided by 1000. And this here 1, this here 8. So that's 1 over 8. That means 8 raised by x equals 1 over 8. 8 raised by x equals 8 raised by minus 1. So you just have to deal with the power. So definitely x equals minus 1. Finish. So I believe that we don't have any problem with this. So whenever you just have things like decimals, try to like express it in fractions. And like I said, there is a big chance that you'll be able to express it in the base of the other part of the equation. And from there you solve. So if you come across questions like that, that's how to like do them. And if you come across different ones, I believe you'll be able to manipulate your way around them. So let's look at further examples under this particular topic. So to continue to our lesson, we have 3 other questions to solve. So solution for D is like the previous one we just did. 5 raised by 2x divided by 1 over. That means for this to be 5, there is a high chance that we're going to express 6 to 5 as an index of 5, right? So basically, can 5 go in 6 to 5? It can go in 6 to 5. Let's look at what is even the root of 6 to 5. The root of 6 to 5 is 25. Like 25 times 25 will give you 6 to 5. Yeah, and just look for root first. Okay. Then if 25 times 25 will give you 6 to 5, then this one is 5 squared times 5 squared times 5 raised to power 4. That means this guy is 5 raised to power 4 here. So can we get our x? It's looking like it's 8. So 5 raised to power 2x will then be equal to 5 raised to power minus 4. And then remember this from the first class. 5 raised to power minus 4 is same as 1 over 5 raised to power 4 we have in this place. So what we'll just do is we pick the indices. So 2x equals minus 4 divided by 2 divided by 2. Therefore x equals minus 2. That's the answer for x minus 2. So like I said, once you see questions like this, there's a chance that you can just bring everything to the same base. So just try to like think it through. You should get it. Now for E, 1 over 4 of 64x equals 16 raised by 3x. Now all of these things are not in the same base, but is there a way I we can express them in the same base? Can 4 go in 64? Yes. Can 4 go in 16? Yes. So it's looking as if we can express this in terms of 4 that's already here. Now, I want you guys to be careful. You can't say 4 here 1, 4 in 64, 16, and you have 16 raised by x. That will be wrong, right? Because the power on 4 is not x. So it's not the same as what is there. So you have to like calm down and chill. Alright. So 1 over 4 is same as 4 raised by minus 1. Off is times. When we express 64 in terms of 4, that's 4 times 4 times 4. 4 raised by 3. And x is going to be here. Okay, 4 times 4 times 4 is 64 equals, then 16 on its own is 4 squared, right? Then 3x. Yeah, that's not difficult. So from there, we are going to be having 4. Remember those okay, 4 is power minus 1 times 4 is power 3x equals 4. Then 2 times 3x multiplication power, that time. Migration of powers, press power 6s. Now that everything is in base 4, so we can just take the bases away and then begin to deal with the indices. So you have minus 1, minus 1, then this times means plus 3x and equals to 6x. Alright, so from here, can we do something? So minus 1 equals 6x minus 3x. So minus 1 equals 3x. X equals minus 1 over 3. So with that, we are done. It's that's is it minus 1/3? Yeah, this is correct. Then finally we have f here, 9381. So we can express everything in terms of 3. So 9 is going to become, so you have to be careful please. 3 going to be 3 squared on its own. Then raised power 2x plus 1 equals, then this 3 raised power 4 on its own, raised power x minus 2, and divided by 3 raised power x. So this 3 raised power 2 into bracket 2x plus 1. So everything has been expressed in terms of 3. So what can we do? Just multiply this, multiply 2 with 2x plus 1. So 2 times 2x is going to give us 4x. Then plus 3 times 2 times 1 is 2. And equals 4 times x, 4x. Then 4 times minus 2, minus 8. Right? Then the power here, since it's a division sign, then this one is also going to become x, minus x. I believe that is clear. So since it's a division sign, so whenever you are dividing, the power subtract each other. So 4x plus 2 equals 4x minus 8, then minus x. So what we are going to see is that you have 4x minus 4x plus x, then equals to minus 8 minus 2. This takes this, so x equals minus 10. So that's the answer to question F. It's as simple as that. So what we are going to have next is going to be our assignment. So again, in case it is a little bit confusing, first thing is you have to do is 9, express 9 in terms of 3, right? So that's going to be 3 squared. Then the power is still outside, which is 2x. I don't know what's wrong with this mark at this point, which is 2x. So you then multiply. So 2 times 2x is 4x. Then 2 times 1 is plus 2. So this side is settled. Then equals 4 times x is 4x, minus 4 times minus 2 is minus 8. And the x here, because of the division sign, comes up to give us a minus x. So from there, what you just have to do is to solve out the algebra until you get your x. So this 2x plus 1, the power of 2x plus 1, the power of 2. Okay, this is 4x minus 2. And then that's the end. So I've solved different variations of indices and exponential functions so that when you see it in an examination, you know what to do. Next thing is an assignment. These are the assignment questions. Let's find the unknowns in all of this. The first one, x raised power 1/3 equals 27. That's simple. Number two, 5 raised power 2x minus 4 equals 25 raised power x minus 8. 25 raised power x minus 8. Then 64/27 equals open bracket 3/4 close the bracket raised power t minus 1. Then 10 raised power x equals 0.000. You have 5 zeros together. Then you have your 1, like including the first one, 0.4 zeros, then 1. Then number 5, this is kind of tricky, but it's so nice. 5/6 raised per half equals 6/5 raised per x minus 1. So again, when you're solving indices, remember that your answers likely are going to be expressed in terms of a base and a power, something like that. Like it's usually not in decimals. Like don't go and quickly convert to decimal, all of that. So it's not often like that. At least if you've seen the examples I've been doing since, I've not been converting my final answers to decimal. So that's it. So next class we'll be looking at logarithms. Thank you and God bless.